Conditional probability and independence. So we're going to revisit, before we start specifically talking about conditional probability and independence, looking back at the Edwards cinema example. And that was on page 19 and 20, that video. So recall that we found some probabilities. Before you continue with this video, I strongly suggest making sure that you can come up with those three probabilities that we found earlier. Okay, now suppose that we want to calculate the probability that a randomly selected resident sees 0 movies a month given she or he is under the age of 30. Now, this is a little bit different than what we've done before. It doesn't say see 0 movies a month and under 30. It says specifically given. This is a condition. You also see the word sometimes if there. This is saying that we're only interested in the people under 30. So how do we write this with good notation? Well, we start with probability. What comes after? This is like the word given. That straight line there. Given under 30, so there's the conditions. The condition always comes second. And we're interested in sees 0 movies. Am I interested in everyone? No, I'm interested in only this column right here, all the people who are under the age of 30. So when I calculate that, I'm going to take the 1900 total, because that's how many are under 30, and then to see the number who sees their 0 movies, and it's 700. And when I compute that out, I get 0.368. Once again, that's specifically that we're looking at just some specific residents. Now, the conditional probability rule for events E and F, for any two events, E and F, the probability of F given E, so we're only interested in those who are in E, is the probability of both of them happening divided by the probability of E. You may be like, well, okay, but how did that work with what we just did? Because we didn't use probabilities. We used counts because we had the table in front of us. Well, what if we didn't have this table in front of us, but we had this information here? Can we do the same thing? Well, let's see. Using the conditional probability rule, this should equal the probability of E and F. So probability that they see 0 movies and is under 30 is 0.14. And the probability that they are under 30 is 0.38. And when you do that calculation, you'll see that you get the exact same probability. So conditional probability, we're given extra information. Words matter, okay? They always do, but in this case, you have to be super duper careful. Order matters here, and you'll see that in just a moment. What I suggest doing is taking a moment, see if you can use the table, and come up with this. What's the probability that a randomly selected resident is under 30 given she or he sees 0 movies a month? I'll give you a hint. It is not 0.368. So I started with the probability under 30 given sees 0 movies. You notice these two are not the same. They're not written the same way because our condition has changed. Kind of like, I don't know, this is a weird, it's kind of lame, but I ate fish. Okay, so I had some, let's say, tuna fish versus tuna fish ate me. Okay, so there's reversing, and one way I'm having a nice tuna sandwich, the other way I'm getting devoured by a tuna fish. Okay, so very different. Now we can do this using the table counts if we wanted to. And in the table, we're looking this time at, let's see, 0 movies a month. So now we're looking at 1,200 here. And we're interested in, remember, that they're under 30 and see 0 movies a month. So there we go, the 700. And you get 0.583. So could it end up being the exact same number? Yes. Would it be unusual? Yes. Now let's do it using the conditional probability rule. Well, we need the probability that there are under 30 NC0 movies. That's 0.14. We have that information here, divided by the probability that they see 0 movies, 0.24. Are both ways valid to get to the probability? Yes, they are, but it'll depend on what kind of information or what information you're given. If you're given a table, you don't need to first calculate the probabilities, you can just use the counts. However, if all you're done is given probabilities, then you're going to specifically need to use that conditional probability rule to answer the question.